Okay, good morning, Team Impact. It is Tuesday, the 26th. All right, we're going to crank this thing out. We're going to be unstoppable today. We got box plots. We did histograms yesterday. The time before that, we did dot plots. We've been into the interquartile range. We've been into measures of center, the mean absolute deviation. Man, we've got all kind of good stuff rolling. Some more of the same. It's called a box plot. Some would refer to it as a box and whisker plot. Okay, so with that all being said, let me pause here just for a second. All right, sorry about that. Let's get rolling here. A box plot display data distribution using five key numbers. The difference between the first and the third quartiles is called the interquartile range. All right, so we're going to overlap with that. All right, so let's talk about these pieces. This is what a box plot looks like. And all of these pieces have, of course, names. The smallest piece of data is the minimum. The median of the lower half of the data is called the first quartile. The midpoint, the median of the data, is the median. All right, we've done all this before. The median of the upper half is the third quartile. Right? And the largest piece of data is called the maximum. Maximum means largest, and I'll let you get caught up there. So if we look at this, here's our minimum. Here's our first quartile right there. This is our median. That is our third quartile. And right there, I like to put a dot there, is our maximum. Okay, is our maximum. All right, so when we're looking to make a box plot, first thing we should do is get organized with our data from least to greatest and then kind of go from there. All right, so the following data points are here. We need to find all of that. So let's get these organized least to greatest here. 34. Let's see here. 45. 47. What else we got here? 48, 48, 49, and 50. 1, 2, 3, 4, 5, 6, 7. We're in good shape. So when I go and do a box plot, what I do is I take care of all of my logistical stuff first. So what I'm going to do here is find the median, right? Here and here, here and here, here and here. There's the median. First quartile would be there. The median of the top half or the third quartile was there. Okay. So what we're going to do is write our information down to the right. No problem here, right? The minimum is 34. Quartile 1 is 45. The median is 48. And you're getting the idea. Now, we're going to make a box plot on the number of animal crackers of this data. Okay? So the first thing I'm going to start with is my box, all right? I'm going to start with the first quartile, which is 45. So I'm going to make that right above there, right above. I'm going to make a line, okay? The third quartile is going to go to 49. I'm going to make that right there. And in between those, the median is 48. So it's going to kind of go right there. And we're going to make this box. Okay? Now, I'm going to take this whisker to 34. And I'm going to put a dot there. And this whisker is going to go to 50 because it's the maximum. And that's your box and whisker plot. Now, what does this represent? All right, so let's talk about this. All right, the box represents 50% of the data. This line is the median, all right? This is the smallest, this is the biggest. But the question is why isn't the median in the middle? All right, well, it depends on the data, all right? So if we think of it this way, this is 25%, this is 25%, 25, and that piece is 25% from there to there, okay? So when we look at that, so if we break it into force, you can see how that breaks out for us, all right? All right, let's go again. All right, number 2, you can pause the video if you want and get organized. All right, here we go. 7, 8, 9, 10. 7, 8, 9, 10. 11, 11, 12. Oh, I missed a 9, didn't I? There was a couple 9s. Did I miss it? Yeah. I gotta go back. So there's a 9, 10, 11, and there was 2 11s. So let's get rid of that. Is there a 12? Yep. How about a 13? No. 14? Yep. 15? Yep. There's a couple of those. And I'm going to kind of go through there so I don't have to rewrite 16 and 19. Okay. So let's go ahead and take care of our data. All right. So let's find the middle number. Here and here, here and here, here and here, here and here. And our median is 11. Median of the bottom half is 9. Median of the top half, I start with 12 and 19, 16, 14 is 15. Okay. All right. So I'm not going to worry about writing all that stuff down because I've kind of wrote over it. I guess I could, huh? Minimum is 7. Quartile 1 is 9. Median is 11, 15, and 19. So now I'm all organized. So let's go to our box plot. Okay. All right. So let's start with the quartile 1 is 9. So I'm going to put a line right there. That 9 right there. The median is 11. I'm going to put it right there. Quartile 3 is 15. I'm going to put it right there. 15, right? Here's my box. What's the box represent? The box represents 50% of the data. Maximum number is 19. Smallest number is 7. So we have our box and whisker. Again, 25, 25, 25, 25% of the data. And we split this data right into fourths. Right? So, good start for our box and whisker plots. All right, let's continue on. Looks like down here they give us a box plot and we have to get some information out of it, sure. All right, so what's the smallest number? It looks to be 11. There it is. Quartile 1. Well, here's 11. Here's 14. What do you think? That's probably about 12, wouldn't you think? The median will be 14. This will be 16, and the greatest number will be 18. Okay, so just reading those things right there makes sense to me. So you should be able to take data from it and data to it. All right, let's flip the page and continue on with the next piece. Christina conducts a poll to determine the number of colleges high school seniors applied to. She creates a box plot to represent the information. All right, good. So we're going to answer these questions from that. Determine the range of the number of colleges. All right. Well, big minus small. Looks like it's going to be 9 minus 0 is 9. 9 colleges, right? Big minus small. What is the median number of colleges? Right there, it looks to be 6. Better label that. What is the inner quartile range of that? So the inner quartile range is the third minus the first. I should pull that down a little bit. The third minus the first. So it's 8 minus 4 is 4 colleges. Okay. And then finally, the last one. Which quartile represents the greatest spread of the data? All right, so now let's talk about this. So when we look at this, all right, the spread of the data, the longer the whisker, the more spread out the numbers are. But you're going to notice that I can't tell specifically how many numbers are in here, right? But I know that they go from 0 to 4. On the top whisker, it only goes from 8 to 9, but there could be 3 9s there. I don't know. All right, but the biggest spread is going to be the first. What has the greatest? Which quartile represents the greatest spread of the data? Is the first quartile. Okay, because it is the longest piece. Describe why quartile 1 is larger than quartile 4. And what do you observe about quartiles 2 and 3? Okay, so the reason this is longer than this, it has a bigger spread. Just talked about that, right? Of data, right? So again, there could be a 0, a 1, a 2, a 3, and a 4. Here could be 3/8 and 1/9. So there's not very much variability, right? And what do you observe about quartiles 2 and 3? Quartiles 2 and 3 are equal, all right? 2 and 3 are, all right, equal, all right, in spread, all right? They're all split. Again, this is still 25%, 25%, and down the line, right? Okay. Take a look at the bottom one. The average monthly rainfall during the summer months and winter months are shown. All right, let's go. So summer and winter, there it is. And it's kind of a double box, so we're reading it off of this. The range in rainfall in the winter was 12. Well, here's winter, the range. So that looks to be 15. And that looks to be about 3. So 15 minus 3 is 12. So that is true. The median rainfall in the summer, right here, was 13. No, that looks to be 11. So that is false. It's 11. For half of the months in the summer, the rainfall was greater than 11 inches. So we go to summer. All right. So for half, remember, this is 25% of the data. This is 25% of the data. So that is absolutely true because those two pieces are greater than 11. Last one. For half of the months in the winter, the rainfall was less than 10 inches. So we go to winter. Here's 10. So for half of it, again, that is absolutely true because this is 25 and this is 25, and that is at, all right, that is at 10 right there. So we're in good shape. Okay, so not a difficult lesson, but just another way to look at data. Again, you can't see specific data on a box and whisker. You can't see specific data on a histogram, but it is good to get a collection of it. If you flip the page, all right, we are rolling on the box plots. Here's your homework. Do a good job. Con is due tomorrow, 7 a.m.